This is an AQA A-level chemistry question on the topic of atomic structure. So take a look at each section, try them, and then review your answers. Here's part A, part B, and finally part C. A total of 8 marks to be collected. So let's go back to part A and take a look. We've got a sample of sulfur with 3 isotopes. We've only been told about 2 of them, but we do know its relative atomic mass. So we've got the relative abundance of 2 of the isotopes. We need to know what the mass number of the 3rd isotope is. So I've color-coded to get lots of the information in so we can see how we're going to get there. I know that my overall relative atomic mass is 32.16. I have been given my relative abundances of the isotope with 32 and isotope 33. So I can call my last one X, and I can also work out what the percentage relative abundance is. It's 7.2 because that's what's left after I add 91 to 1.8. I'm dividing all of it by 100 because this is a percentage abundance. Now, once I've done that, I can rearrange those numbers a little, and from there, I can simplify a little more, and from there, I can work out my value of X. It's 33.97. However, I can't put that down as my answer. It's an individual isotope of an element, so it has to be an integer value. So I'm going to round that to 34. Moving on to part B, describe how ions are formed in a time-of-flight mass spectrometer. Straightforward factual recall here, you have got to remember. I'm actually answering here on the electron impact method. You could also talk about electrospray. So in the first instance, sample is bombarded by high-energy electrons. That high energy is absolutely crucial. And then what happens when they hit? Well, the sample molecules lose an electron to form the M+ ions. Finally, moving on to part C, a time-of-flight mass spectrometer can be used to determine the relative molecular mass of molecular substances. Why do we need to ionize? Well, there are 2 specific parts of this process that absolutely rely on our species being ionized. In the first instance, you need to have ions so that they can be accelerated by an electric field. So we're linking it to the acceleration stage. We also need them to be ions so that they can be discharged at the end in the detector. When they're discharged, they create a current. And it's the currents that we can then measure, and it's proportional to the abundance of the different isotopes. And just to clarify at the bottom in red, molecules would not be accelerated by an electric field, and molecules would not create a current when they hit the detector. That takes us to the end of this question. Thank you for listening.